All right, so this is, I'm going to start with 6 and 7, which are over here. So, Audrey, you're going to have to walk me through because, like, obviously I see the answer, but I want to see where you got lost. Oh, so let me start with 5. So where'd you get stuck on 5? You said it was just so long because of all the possibles?
Yeah, I don't know because I tried to do, so like I don't know what the L thing is called.
Synthetic division.
Okay, synthetic division. So I did it, but then like I couldn't remember because like I only got 3 answers.
Okay, so which is the first one that you got that worked? Did you get -2?
7, 4. Oh wait, no, just kidding. That's the wrong one. I was looking at the wrong problem.
Yeah, no, 5.
The first one that I got that worked was 3.
3. Okay, so we'll do 3. So 3, and then it's 9, -9, -58, 4, and 24. So then I get 9x to the third plus 18x squared minus 4x minus 8. And then I would see if this is factorable because it's 4 terms. See if you can factor by grouping. So from the first one, you can actually take out a 9x squared and you get x plus 2. And from the second one, you can take out a -4 and you get x plus 2. So then I get x plus 2 and 9x squared minus 4. And that 9x squared minus 4 is the difference of 2 squares. So you can actually go further, 3x plus 2 and 3x minus 2. And then you get -2, -2/3, and +2/3. 1, 2, 3, and the 3 that came from your answer should be the 4th one.
Okay.
You good?
Oh yeah, because then the -2/3 are... Okay, I see it.
How do you see the right answer on WebAssign?
Now when you go back in at the very top, there's a thing that says show key.
Okay, thank you.
You're welcome. So it happens after 8 a.m. on the day. It's like, so after the due date, immediately after, you can start to go back in and see show key. All right, number 6, it says find all the real ones. So again, you've got to do the possibles. So now it's plus and minus. It would be 1 and 2 over 1 and 5. So I'd get plus and minus 1, 2, 1/5, and 2/5. And then 1 worked. So 1 on the outside, -5, 11, -4, -2, -5, -5, 6, 6, 2, 2, 0. And I get -5x squared plus 6x plus 2. So then I would see if I could factor this, see if there's factors of -5 times 2. -10, that sum to +6. And there's not, so I have to use the quadratic formula. So A is -5, B is 6, and C is 2. -6 plus and minus the square root of 6 squared minus 4 times A times C all over 2 times A. -6 plus and minus the square root of 36. This is 20 times 2, so plus 40 over -10. And I get -6 plus and minus the square root of 76 over -10. 76 is 2 and 38, 2 and 19. So -6 plus and minus 2 root 19 over -10. And then those are each divisible by 2. -3 plus and minus root 19 over -5. So the way they have the answers typed in, they actually get rid of, they bring out the denominator. So I'm curious if it if it would mark it wrong, if this is how you left it. Like if I left it as -3 minus root 19 over -5, so that would all change. So 3 plus root 19 over 5, and then -3 plus root 19 over -5 would be 3 minus root 19 over 5. If you gave those answers with the 1 you got from the beginning, from the synthetic division, I would take it like that. It looks like WebAssign took out a 1/10, so I'm curious. Did anybody get this question right by typing it in with the fraction on it? I think it still works. This answer for me works. So WebAssign, again, it took out a fraction. It took it out before it even simplified it. So it took it out up here. It took out a 1/10. To take out a negative 1/10? No, 1/10. And then it was -6 plus 2 root 10. And then 1/10 -6 minus 2 root 19. But I am good, again, with this. You can leave it in fraction form. You don't need to pull that fraction out. Audrey,
So when they're like that, you just have to find one of the possible roots that work?
Yeah.
Or you have to try all of them?
No, once you get one, so because, look at your initial question, right? This is so important. So the initial question, the degree is 3. Remember, degree is highest exponent. So the degree is 3, which means there's 4 terms usually, and I can try to factor by grouping, but it's not going to happen. That's just not that's not the type of problem you're going to get here. So if it starts with a 3, then my goal is to find one root using synthetic division, and it will reduce it a degree. So it goes from something x to the third to something x to the second. Once I get it to x squared, which means it's quadratic, I can either factor it or use the quadratic equation or quadratic formula. But from there, I can find the answer. So all you have to do is get it. Your goal is to get it to be quadratic, and then you can use quadratic formula.
Okay, but if it was like to the 4th?
Which is this one, right? Like 7.
Yeah.
So let's do that one. So you got the -6. Well, it would be plus and minus 1, 2, 3, 4, 6, and 12, because there's the leading coefficient's 1, right? So let's just say you got the -6, which probably not. Probably you got the 1. Let's say, I would say most people probably got the 1 first. 1, 9, 12, -34, and 12. 1, 1, 10, 10, 22, 22, -12, -12, 0. So now I've got this x squared, x to the third. X to the third plus 10x squared plus 22x minus 12. Now I have 4 terms, so if I could factor by grouping here, I'm good. But you can't factor by grouping there. Which means you have to find another root. So I have to go back to synthetic division and find another one that works. If you went in order, you would have done -2 and 2, it didn't work. -3 and 3 didn't work. -4, probably, if you went in order, is the next one that you would have tried. Wait. Oh, that was your answer, which was wrong. Sorry, just kidding. Hang on. -4 did not work. You had to go all the way to -6. That's super fun. I'm sure you guys really enjoyed this homework, and I'm sure you weren't thinking ill of me in any way, shape, or form. -6, 4, -24, -2, +12. There's your 0. Now it's quadratic. And I don't have to do any more possibles once it's quadratic, because even if it's not factorable, which this is not, there's no factors of -2 that sum to 4, I can do the quadratic. So A is 1, B is 4, C is -2. So it's -4 plus and minus the square root of 4 squared minus 4 times A times C all over 2 times A. -4 plus and minus the square root of 24 over 2. This is 4 and 6. So -4 plus and minus 2 root 6 over 2. All of those are divisible by 2. And I get -2 plus and minus root 6. So this time there's 2 roots that worked from synthetic I have to include in my answer. -6, +1. And then the 2 I got with quadratic, -2 minus root 6 and -2 plus root 6. So all 4 of those were the answers. And again, it should be just as many as you have an exponent. So if it's x to the 4th, if I count all the roots, real roots and non-real and double roots, it should be the same amount.
And then to solve 10 and 11, you do the same?
So 10 and 11. Yes, the only difference is once you get the first root. Okay, so if I do 10, Negative 1 did work. So negative, oops, a daisy. Negative 1, 1, negative 3, 1, 5. Bring down the 1. Negative 1, negative 4, 4, 5, negative 5. X squared minus 4x plus 5. No factors of positive 5 add up to negative 4. If it was a negative 5, you'd be good, but it's not, which means quadratic. So A is 1, B is negative 4, C is 5. So the opposite of negative 4 is 4. Plus and minus the square root of negative 4 squared minus 4 times A times C all over 2 times A. 4 plus and minus the square root of 16 minus 20 over 2. 4 plus and minus the square root of negative 4 over 2. Now I've got an imaginary number. 4 plus and minus 2i over 2, which is 2 plus and minus I. So the first root that worked was the negative 1, and then the other two are imaginary, but they're still part of my roots. So the answer would have been negative 1, 2 minus I, 2 plus I for the second question, which said list all the zeros. And then for the first question, remember we do x minus before each of these. So x minus a negative 1, x minus 2 minus I, and x minus 2 plus I. This becomes x plus 1. The signs always change. X minus 2 plus I and x minus 2 minus I. And this is the linear factored form. So a product of linear factors, that's what it looks like. So Nate, does that answer your question? In order to write it as a factor, remember that there's two things. There's roots, right? And then you're saying something's a factor. If it's a factor, then we do it in parentheses, x minus whatever it is, which always changes the sign.
Wait, but where'd you get the x plus 1? Oh, is it so the minus 1 in front, you put x plus 1 instead of x minus 1 because
it'd be x minus a negative 1, and it always changes signs.
Okay.
Does that make sense? So when we list them, whatever those signs are, it's going to be the opposite signs if you write them as a product of linear factors.
Okay.
Because if I solve x plus 1, I get negative 1, right? If I set that equal to 0, I solve it. So that's why it's written that way. So the same exact thing happened with number 11, except that I'll work out this last one and then we'll switch to the notes, and then I'll go back to these if I need to at the end, but I have a feeling a lot of you have the same kind of questions. So 1, negative 4, 8, negative 16, and 16, and my possibles were plus and minus 1, 2, 4, 8, and 16. So the first one that worked was 2. Bring down the 1, 2, negative 2, negative 4, 4, 8, negative 8, negative 16, 0. So then I'd get x squared, x to the third, minus 2x squared plus 4x minus 8. And this can get factored by grouping. Take out an x squared, x minus 2, take out a 4, x minus 2, x minus 2, x squared plus 4. So this means that there's another 2. There's this one, and there's this one, which again, remember I said is important when we get to today's stuff. Oh, I lied yesterday and said that there wasn't a repeated root, and there was. You just didn't need to write it. And then this has to get solved using either the quadratic formula or the even root property. So I can set this equal to 0, x squared equals negative 4, x equals plus and minus the square root of negative 4, which is plus and minus 2i. There's your other two roots. So all four roots would be the 2, and it's twice, and then a negative 2i and a positive 2i. You don't need it the second time. So when you write out the linear factor, you need it because there are 2 of them, x minus 2, x minus 2, x plus 2i, and x minus 2i. You need it here, but if you're just listing the real roots, you don't need it. But you will see today that it's called the multiplicity of a root, and that is important when we get to graphing these.
Can you zoom out? See the other problem, please.
So did that answer other people's questions that I don't then need to duplicate? Did anybody else?
Problem, please. The one in blue.
The one in, which one, at the top or on the left?
Yeah, 10.
10. Okay, this was Sophia's. So 9A is the possibles. So 50 breaks down into 1 and 50, 2 and 25, and then 5 and 5. And 7 is 1 and 7. So all of these have to go over all of those. So 1 goes over 1, and 7 goes over 1. Then 1 goes over 2, and 7 goes over 2. Then 1 goes over 5, and 7 goes over 5. Then 1 goes over 25, and 7 goes over 25. And then 1 goes over 50, and 7 goes over 50. That's your possible bank. 11 gave you this. It asked you for the linear factors, right? So I got to figure out the possibles first. This would be 1. This is 1, 3, and 9. So plus and minus 1, 3, and 9. If I try 1, it works. So then I get x to the third minus x squared plus 9x minus 9. And that I can factor by grouping. Take out the x squared. Take out the 9. X minus 1 becomes equal to 0, and that's x equals 1. X squared plus 9 equals 0 would be x squared equals negative 9. Plus and minus the square root of negative 9, and I get plus and minus 3i. So I have 2 1s and a plus and minus 3i. When I list it, it's 1, negative 3i, and positive 3i. But when I do my linear factors, there's 2 1s. So you have to have both. And then an x plus 3i and x minus 3i. Tamil, this one was yours. So 34 is 1, 2, 17, and 34 over 1. So plus and minus 1, 2. So if you try the positive 1, 1, negative 6, 1, 34. Doesn't work. Try the negative 1. Actually, I cheated. I know the negative 2 works. Negative 2. There's the one that works. And then there's no factors 17 that sum to negative 8. So we do the quadratic. A is 1. B is negative 8. C is 17. The opposite of B. So 8 plus and minus the square root of B squared minus 4 times A times C over 2A. This is 68. 8 plus and minus the square root of negative 4 over 2. 2i over 2, and that's 4 and 1. So 4 plus I, 4 minus I, and the negative 2. So when I list my roots, they look like that. Linear factors, I would do x minus a negative 2, so it changes the sign. X minus 4 minus I changes both those signs. X minus 4 plus I changes both those signs. Okay, here's the questions. These are Madison's questions. So the first one was asking for all the roots. So the first thing you have to do is list out all the possibles. So the first one is 9, which means it's 1, 3, 9, and the last one's 24. So 1, 2, 3, 4, 6, 8, 12, and 24. And then you have to do plus and minus all the last over the first. So all of them would go over 1. Then all of them would go over 3. So 1/3, 2/3, 3/3 is 1. You already have it. 4/3, 6/3 is 2. We already have it. 8/3, 12/3 is 4. You already have it. And 24/3 is 8. We already have it. Then we put them all over 9. 1/9, 2/9, 3/9, which would be 1/3, and we already have it. 4/9. 6/9 is 2/3. We already have it. 8/9. 12/9 is 4/3. We already have it. And 24 over 9, which is 8/3, and we already have it. So here's our possible bank. Then you want to try to see which ones are going to work. So I know that negative 2 works, which is probably the first one. If I had gone 1, -1, 2, -2, that would have been the first one that works. So 9, -9, -58, 4, and 24. Bring down the 9. 4, -4, -8, so +8, sorry, 12, -24. There's your 0. Now I look at this, 9x to the third minus 27x squared minus 4x plus 12. And I want to see if I can factor by grouping. So I can take out a 9x squared from here, and I get x minus 3, and I can take out a -4, x minus 3, so it's x minus 3 and 9x squared minus 4. Then 9x squared minus 4 becomes 3x plus 2 and 3x minus 2. So I get +3, -2/3, and +2/3. This, and the -2 are the roots. Number 8, ask for the possibles, the graphs, and then the actuals. So my possibles are 1 and 2, 1, 2, 3, and 6. So it's plus and minus 1, 2, 3, and 6. And then all of them over 2. So 1 over 2, 2 over 2 is 1, 3 over 2, and 6 over 2 is 3. You already have it. Then you're going to graph it, and it looks like this. So from here, you can actually eliminate, because you get -1. This would be 1, and this would be 2. Actually, this would be -1/2. So you can actually eliminate a lot of your possibles. What I would do is just grab an easy one like 1, put it on the outside, -2, 11, -16, 1, and 6. Bring down the -2. And then I've got -2x to the third plus 9x squared minus 7x minus 6. Not factorable, so yet. So go back to your graph, find the other one, which is 2. Put 2 on the outside, -2, 9, -7, -6. And now I get -2x squared plus 5x plus 3. So even if it's not factorable, we can use the quadratic formula. But if I do -2 times 3, that's -6. Factors of -6 that sum to +5 would be +6 and -1. So I get -2x squared plus 6x minus x plus 3. Factor by grouping. Take out a -2x. Take out a -1. X minus 3 and -2x minus 1. And I get a +3, -2x equals 1, x equals -1/2. So I have -1/2, 3, 2, and 1 as the roots, which, oh, there's the 3 there. So you'd also have seen that from the graph. Those are your actual roots. Number 9, same thing. So plus and minus. Now I get 1, 2, 3, 6, 9, and 18, and 1 and 5. So I'd get 1 over 1 and 5 over 1. Then I'd get 1 over 2, 5 over 2. Then 1 over 3, 5 over 3. Then 1 over 6, 5 over 6. 1 over 9, 5 over 9. And 1 over 18, 5 over 18. Then do the same thing. Graph it again. So this time, the only whole number that I can see is the 1. So I'm going to put the 1 on the outside, 18, -45, 22, and 5, 18, -27, -5, -5. And I have 18x squared minus 27x minus 5. Now I want to see if that factors. So 18 times 5 is -90. Factors of -90 that sum to -27 is -30, +3. So then 18x squared minus 30x plus 3x minus 5. Factor by grouping. And I take out the 18x here. I'd get x minus, not 18, sorry. Take out the 6x. X minus 5 and 3x minus 5. And then the +1 is already there. 3x minus 5, 3x minus 5, and 6x plus 1. That's a +5/3 and a -1/6. So -1/6, 5/3, and +1 are your actual roots. Okay, 11 said this, and it just said to find the roots. So this is 1 and 81, 3 and 27, 9 and 9. So plus and minus over 1. So I would start testing those points. I would go through -1 and 1. It doesn't work. I would go through 3 and -3. So this is 1, -6, 18, -54, 81. Bring down the 1, 3, -3, -9, 9, 27, -27, -81. And there's your 0. X to the third minus 3x squared plus 9x minus 27. Factor by grouping. Take out the x squared here. And I get x minus 3 and x squared plus 9. So the x minus 3 gives me a root of 3, but x squared minus 9, plus 9 would be x squared equals -9. X would equal plus and minus the square root of -9, which is plus and minus 3i. So the first 0 is 3, the second one is 3, and then positive and negative 3i. When you're listing these, you only need the 3 once, but when you're giving it as a product of linear factors, it would be x minus 3 because there was 2 of them, then x plus 3i, and then x minus 3i. Okay, Vanessa, here's number 6 of yours. So -6x to the third plus 11x squared minus 3x minus 2. You've got to do your possibles. So plus and minus, factors of the last, which would be 1 and 2, over the first, 1, 2, 3, and 6. So the 1, all of them go over 1, 1 and 2. All of them go over 2, 1/2, and 2 over 2, which goes back to 1. You already have it. All of them go over 3, 1/3, 2/3. All of them go over 6, 1/6, 2/6, which is 1/3, and we already have it. So this is my possible bank. So then I want to try them. If I try positive 1, -6, 11, -3, -2, bring down the -6, -6, 5, 5, 2, 2, and that one works. So I'm going to take -6x squared plus 5x plus 2. See if I can factor it. So -6 times 2, -12. Factors of -12 that sum to positive 5. There's none. So I have to do the quadratic formula. A, -6, B, 5, C, 2. -5 plus and minus the square root of 5 squared minus 4 times A times C all over 2 times A. -5 plus and minus the square root of 25. This is 24 times 2, 48. 25 minus 48, -23 over, actually that's a positive 48 because it's a negative times a negative. Hang on, this becomes 73 over -12. So your other two roots are -5 minus root 73 over -12, -5 plus root 73 over -12. We don't want the negative in the bottom, so when you list them, it's going to be the one that we got, and then change your signs here. So 5 plus root 73 over 12, and 5 minus root 73 over 12. And those are your 3 roots. And Madeline, here's yours. Actually, Madeline, your number 10 is the same as Tamil's. So if you rewind a little bit, I already did that one. And 11 is the same as Sophia's. So if you want to rewind again, that one's before Tamil's. So we went back, okay, to 3-2, which is called polynomial functions of higher degree. So we're basically, what you just found the roots of, those polynomials, we are now going to learn how to graph them, okay? So there's a multi-step process that we're going to put together all the way at the end, but there's these little things along the way that help you graph something that is not necessarily a parabola. So these could be parabolas, but they also could be x to the thirds, x to the fourths, x to the fifths that don't necessarily take on a standard shape that we can shift around. So the first thing we use that helps us is called end behavior. And there's 2 ways to... All right. So the first thing you want to do is get your function in decreasing degree order, as usual. Then you want to look at the highest exponent. That's the degree, okay? So the degree is the highest exponent. That degree is either going to be odd or it's going to be even. If it's odd, then one of your end, so the things that's happening on the left and the thing that's happening on the right, that's your end behavior. One of your arrows is pointing up and one of them is pointing down. If the exponent is odd and the number on the front, so we do this with like an A, X, and the exponent is odd. If the exponent is odd and the number on the front of it is positive, then the graph falls left and rises right. So the arrows point down to the left and up to the right. If it's an exponent that's odd, but the leading coefficient is negative, now it reverses. It rises left and falls right. So it rises left and it falls right. The second thing is if it's even. So if the highest exponent is even, like a 2, a 4, a 6, an 8, so on and so forth, then both the arrows point in the same direction. If it's even and the number on the front is positive, both point up just like a regular parabola. And if it's negative, both point down like a parabola with a negative on the front. So this is called end behavior. And it's called the leading coefficient test. So you'll kind of see those two things interchangeably. Use the leading coefficient test to determine the end behavior, is usually what it says. The second thing we're going to use is the zeros of the function. Remember, the zeros are where it crosses the x-axis. It's also called as a root or a solution, okay? If it's a real root, then it's an x-intercept. So if my graph goes up and down and up again, everywhere it crosses the x-axis is a 0 or an x-intercept. The multiplicity of these roots depends or determines what happens at that point. Does that graph cross through like this graph does? It crosses through each of these points, or does it bounce at one of those points? So if, let's say, this was a 0, but it bounced, that's what it would look like. So it bounces here and it crosses through here. And the way you determine that is how many times a root occurs. If it occurs an even amount of times, then it hits it and turns around or bounces. If it occurs an odd amount of times, it crosses through. And this is why when we were talking about it yesterday, and I said if you get a root that happens more than once, this is why it's important. If I get the same answer twice, it bounces at that coordinate point. If I get the same answer an odd number of times, like once or 3 times, it crosses through the graph at that point. All right, so this says find the end behavior, the zeros, and the multiplicity. So the first thing we need to do is make sure this is in decreasing degree order. Is it?
Yes.
Good. So then what's the degree of this polynomial or the highest exponent?
Cubic.
Good. And is 3 even or odd?
Odd.
Odd, which means one arrow is going up, one arrow is going down. So then I look at the front. Is that a positive x to the third or a negative x to the third?
Positive.
Positive, which means it rises right and falls left. That's the end behavior. Falls left, rises right, just like a normal x cubed, right? If you think about your parent function for x cubed, it went up to the right and down to the left. Now we want to find the zeros. So I want to take my initial function and set it equal to 0. And what do we do with 4 terms? Say again.
Group them.
Good. Group them. So from the first parentheses, I can take it an x squared. Second parentheses, negative 4. And I get x plus 2 and x squared minus 4. X squared minus 4 is the difference of two squares, so I can go one more step and make it x plus 2 and x minus 2. So my roots are -2, -2, and +2. So those are the zeros. And when we write zeros, we just list them. Now, I only need to include the ones that don't repeat for when I'm listing them, but I want to pay attention to the multiplicity. So because there's two -2's, the multiplicity on that is 2. So it would look like -2 with a multiplicity of 2, and then 2 with a multiplicity of 1. You actually don't need to write the multiplicity of 1. If you don't include multiplicity, it's assumed it's 1. But obviously, you want to identify if it happens more than once. So if I'm writing this like on the homework, I actually would just like put a little 2 right next to your one that has a multiplicity of 2 and then leave the other one. But if you see this as like an answer, this kind of question, I think I'm trying to picture your test, is multiple choice, that would say it like in written format like this.
Where did you get that?
That's how many times that answer occurs.
Oh, okay.
We ready to try another one?
So like on our test, if it appeared like twice, you would do -2 multiplicity of 2, right?
Yes.
Okay.
Because what does that tell you? What happens at -2 then?
Isn't it like crossing twice because it's repeating like the zeros are?
So instead of it crossing, it actually bounces because it's an even amount, right? So like just think about what we know already about this graph. We know that the arrow points left, down, right, up, that it's going to hit the graph at -2 and at +2. So already I know it looks like this. It looks like this. I know it has to bounce here, so it's going to bounce. I don't know how far down it's going to go, but it has to come back up to hit that 2. So we're going to use things like your Y-intercept to help you figure out how far down that goes.
So the end behavior is odd and the multiplicity is even?
No.
For this problem?
The end behavior is falls left, rises right. The degree is odd. But that's what determines the end behavior.
Oh.
This is end behavior. And then zeros, zeros are -2 and 2. Multiplicity is of -2, the multiplicity is 2. Of +2, the multiplicity is 1.
Okay.
All right, so we're going to go a step further and say, how do I actually graph this thoroughly? I'm going to first determine the end behavior. Then I'm going to find the zeros in the multiplicity. Then I'm going to find the Y-intercept and hope that helps me. If not, I have to plug some extra points in to see how far down or how high up my graph goes. All right, so let's look at this question. It says, graph f of x equals x to the third minus 2x squared minus 5x plus 6 using what you've learned in this section. Hang on just a second. This is in decreasing degree order again. Highest exponent's odd. Number on the front positive, which means this falls left and rises right. I actually am going to change this. Make this a 3. Let's start there. Make that a 3 at the beginning. I'm going to change the 5 to be a 3. Let's make it a little bit easier on us at the beginning. Hey, there's a lag. Hang on. Change the -5 to a 3. Let me stop sharing and reshare.
Positive or -3?
You can keep it, you need to keep it negative. Like that. All right, again, end behavior, falls left, rises right. Then we would factor by grouping to figure out my zeros. So I'm going to group this. Take out the x squared, x minus 2. Take out the negative 3, x minus 2. And I get x minus 2, x squared minus 3. Now that's not a perfect square, so I would solve it by saying x minus 2 stays. This would be x squared equals 3, and x equals plus and minus the square root of 3. This would be 2. So when I list my zeros, I'm going to have negative square root 3, positive square root 3, and positive 2. The multiplicity on each of those roots is 1 because they only occur one time, which means it's going to cross through each of those points. So I want to plot those points. Root 3 is pretty close to root 4, so we're going to say maybe this is like a negative 1.8 and then a 1.8. I think it's 1.7 actually, but close enough. I'm going to go to that negative 1.8, which is like here. And I'm going to arrow down because I know it falls left and rises right. Then I'm going to go to my 1.8, which is here. And my 2. I know it's going to cross through each of those points, which means it's coming up here. And I need to figure out how high up it goes. So the last thing I can use before I just plot in some regular points is the y-intercept. So if I plug a 0 in, 0 x to the third, 0 into the x to the third, then 2, 0 squared minus 3, 0 plus 6, I get 0, 0, 0, and positive 6. So 0, 6. Now I know how high up it goes. So my graph is going to go up. It's going to come back down, go past this and through it, come back up again because it has to cross through those points. And the left side has to arrow down and the right side has to arrow up.
How do you know like how far down it goes in between the 1.8 and 2?
So normally, because I just like changed that number on its own, I would say normally you would have something in here that you'd want to plug in. So it would be really hard to plug in like a 1.9 here without a calculator especially. But normally it'd be something where there's a space that you would plug in a value there.
Okay.
So now I'm going to go back and redo this the way that it was so that we can see what would happen if we didn't know those roots. So if it's which we haven't come up with this part of your test yet, I think you're going to do like one big question like this. Let's say it's a test and you need to know how far down to go in between those places and you're graphing it by hand. You're going to plug in a value.
Oh, okay.
Yep. So like, let's say we crossed through at positive 1 and came back up at positive 3. We would plug in 2 to see what happens there, which you're going to see. I'm going to show you an example in a second where you'll do that. Let me just go back. All right, so let's...
if the multiplicity is like more than 1, how would you like plot the point twice on the same
You
number?
don't plot it twice. It just tells you, do you cross through that point or do you bounce? So if the root occurs an even amount, let's say it happens twice, it's going to bounce. If it occurs an odd amount, it crosses through. We do have examples in which it's going to bounce. Hopefully I'll get to them. I don't know if I'll get to one today, but obviously we'll get to it by the end. This one I'm going to do, this one they cross again. So I'm going to kind of work through this a little bit faster just because we already did the end behavior, right? The highest exponent is to the third and it's positive. So this falls left, rises right. In order to get the zeros this time, I have to do my possibles. Plus and minus 6 is 1, 2, 3, and 6 over 1. So plus and minus 1, 2, 3, and 6. And then I've got to start trying to see which one works. So I'm going to start with the positive 1. 1, negative 2, negative 5, 6. And that works. So that's the first root. Then I take x squared minus x minus 6. And I see if I can factor that. I can. Negative 3, positive 2. And I get 3 and negative 2. Now I have my other two roots. So the 3 zeros. So here's the first answer. That's my end behavior. Then my zeros are negative 2, 1, and 3. They each only occur once, so the multiplicity is 1. The last thing I need is the y-intercept. Plug 0, 0, 0, and I get 0, 6. Now I go to the graph. So I'm going to plot -2, 1, and 3. My arrows down left, up right. My y-intercept is 0, 6. So I know it goes up to there. It's going to come back down because it has to cross through here. Now I need to figure out how low does it go here. And for that, I plug in a +2. So 2 to the third minus 2 times 2 squared minus 5 times 2 plus 6. 8 minus 2 times 4 minus 10 plus 6. 8 minus 8 minus 10 plus 6. These cancel. -10 plus 6 is -4. So now I know when my x is 2, my y is -4. And then I know it goes down, and I know it has to come back up because it has to cross through that 3.
Wait, why'd you plug in 2?
Because that's the space that was here that I knew it had to come down through here, and I knew it had to come back up through there. So I had to figure out how low does it go in between those two spaces. So I would say, sorry, my husband just started saying, how low can you go? Can you go down low? You play the cha-cha slide. By rule of thumb, I would say that for every point pairing, you need 1 point in between. So in between these 2 points, I had the y-intercept. I didn't need to plug in another point. But in between this point and this point, I didn't know how low to go, so I have to plug in another point.
Okay, thank you.
You're welcome. All right, let's another one. Graph y equals 2x to the third minus x squared minus 25x minus 12. So start with end behavior. Is it in decreasing degree order?
Yes.
Yes. Highest exponent is even or odd? Odd, which means one's going up, one's going down. Positive or negative? Positive, which means falls left again, rises right. Now I've got to get my zeros. Can I factor this?
No.
No. So it's 1 and 2 here. 1, 2, 3, 4, 6, and 12 there. So my possibles are plus and minus. 1 over 1, 2 over 1, 3 over 1, 4 over 1, 6 over 1, 12 over 1. And then all those over 2. 1 over 2, 2 over 2, which is 1, and I already have it. 3 over 2, 4 over 2, which is 2, I already have it. 6 over 2 is 3, I already have it. 12 over 2 is 6, I already have it. So now I'm going to test my possible roots. So I think, let me go to my table. I'm going to cheat because I'm pretty sure there's one at, nope, hang on. I think 4 works. Just for time's sake. Obviously, then you got to check it. But 4, 2, -1, -25, -12. Yep. All right, so that was 4. Again, I just did it for the sake of time. Normally, you'd have to test them out. Now I get 2x squared plus 7x plus 3. And I want to see if this is factorable. 2 times 3 is 6. Factors of 6 that sum to 7. 1 and 6. Replace the middle with those. Factor by grouping. And there's my other two roots. So I have 3. My zeros are -3, -1/2, and +4. The multiplicity of all being 1. The other thing I can find is my y-intercept. If I plug 0, 0, 0 in, I get 0, -12. So now I'm going to plot -3, -1/2, +4, and my y-intercept, which is -12. So it all the way down here, -12. This arrow points down, this arrow points up, and it crosses through each of these. So to figure out how high I'm going to go here, I need to plug in a point because I don't have one. So I'm going to plug in, I can even just plug in -1. You can plug in -1 or -2, it doesn't matter. So -1 to -1 to the third minus -1 squared minus 25 -1 minus 12. -2 minus 1 plus 25 minus 12, that's -3, 22, and that's 10. So all the way up here, it's going to go all the way up. It's going to come all the way, nope, not there. Yep, all the way back down. It's going to go all the way down to -12 and come all the way back up again.